before it becomes the world's internal concave grates, strip automated arms rack before it becomes the world's most popular pasta. Spaghetti begins as hard amber durum wheat, standing tall in the sun.
This specific strain is cultivated for its density and protein, the structural backbone of the pasta noodle.
Industrial harvesters sweep across the plains, separating the grain from the chaff in a single continuous motion. Internal concave grates strip the kernels, ensuring only the nutrient-rich heart of the plant is retained.
The transfer is seamless, keeping the harvester moving to maximize the yield during the short harvest window.
Loaded with 40 tons of potential energy, the cargo begins its journey to the milling facility.
The cold chain is less critical here, but moisture control during transport is vital to prevent premature sprouting.
Every shipment is weighed and logged, integrating the raw tonnage directly into the factory's production schedule. Automated samplers verify the protein count, and if the durum lacks hardness, it is rejected before entering the mill. Gravity does the initial work, feeding tons of raw material into the subterranean intake network.
Bucket elevators transport the cargo to the highest point of the facility, using gravity to feed the milling process later.
Stored in temperature-controlled concrete giants, the wheat waits for the milling that will transform it into semolina.
Before a single noodle is formed, the raw grain traverses a pneumatic highway into the milling wing.
Inside this fortress of concrete and steel, the hard wheat will be pulverized into coarse, golden semolina.
Automation drives the line, but skilled technicians remain the guardians of food safety and quality. Strict hygiene protocols are the first line of defense, creating a sterile barrier between the outside world and the food. Every entry point is mechanically guarded to ensure that only the highest standards of cleanliness reach the production floor. Crossing the threshold, we enter a high-decibel environment where science and tradition collide.
Before processing, powerful rare earth magnets strip away ferrous contaminants picked up during the harvest.
Vibratory separators use simple physics to segregate the harvest, discarding any debris larger or smaller than a wheat berry.
Using specific gravity, the destoner floats the wheat on a cushion of air, while heavier rocks sink and are ejected.
Optical sorters analyze color and reflectivity in microseconds, ensuring only the healthiest kernels become spaghetti.
Scouring friction cleans the outer bran, removing dust and microbial spores to ensure a sterile flour base. Tempering adds precise moisture to toughen the bran, ensuring it peels off cleanly during the grinding phase. Corrugated break rolls crack the kernel open, carefully separating the outer bran from the golden endosperm inside. Stacked sieves oscillate rhythmically, sorting particles by size and sending them back for regrinding or purification. Air currents lift away the remaining lightweight bran, leaving only the pure, coarse semolina required for pasta. The result is semolina, the coarse, amber heart of the wheat, ready to be hydrated into dough. Vacuum mixing removes oxygen to preserve the yellow color and ensures a dense, bubble-free structure. Extreme pressure fuses the hydrated particles into a solid, plastic mass, ready for the final shaping.
Bronze dies create a microscopically rough surface, essential for holding sauce, unlike smooth Teflon molds.
Gravity straightens the strands as they descend, ensuring the classic linear geometry of the noodle.
Precision cutters slice the continuous extrusion into uniform lengths, ready for the drying racks. Automated arms rack the fresh pasta, preparing it for the most critical phase, dehydration.
A rapid blast of hot air sets the outer skin, preventing the strands from sticking together.
Gradual drying over several hours prevents cracking, slowly stabilizing the internal structure of the starch.
Once cured to a 12% moisture content, the rods are mechanically stripped, releasing the brittle pasta.
Diamond-tipped saws trim the ends to the millimeter, recycling the excess semolina back to the beginning.
Accumulation buffers act as a time machine, storing production flow to ensure the packaging line never starves.
Vibratory channels tame the chaotic flow, aligning thousands of individual strands for the weighing heads.
The system grabs the bulk weight first, speed taking priority over absolute precision in this initial stage.
Fine dosing channels add the final strands one by one, achieving a weight accuracy of a fraction of a gram.
Flow wrappers envelop the portion in a continuous sleeve of film, the first layer of protection against the elements. Thermal jaws seal the ends instantly, creating an airtight environment to preserve shelf life for years.
Dynamic check weighers reject any pack deviating from the standard, ensuring the customer never pays for error.
Laser etching permanently marks the lineage of the batch, a digital passport for traceability.
X-ray systems see through the density, hunting for glass, stone, or high-density plastics invisible to metal detectors.
At peak capacity, these lines process hundreds of packets per minute, a symphony of synchronized automation. Random samples are subjected to the ultimate stress test, boiling water, to ensure they hold their shape without starchy sludge. The cross-section reveals the hydration gradient. A faint white core confirms the density required for true al dente texture. Texture analyzers simulate the force of a human jaw, quantifying the bite to ensure consistent firmness in every batch. Structural flexibility is tested to guarantee the dry product survives the vibration of transport without shattering.
Colorimeters verify the signature golden hue, a direct indicator of the high-quality carotenoids preserved from the wheat.
While machines measure physics, only the trained human palate can certify the subtle flavor profile of the Durum wheat. Secondary packaging calculates the optimal spatial arrangement to minimize air gaps during shipping. Robotic palletizers build stable, interlocking layers capable of withstanding the vibration of international transit.
A final layer of tension film unitizes the load, weatherproofing the cargo for the long haul.
From the golden fields to the shipping dock, the process is complete, ready for global distribution.
And this is how modern factories produce spaghetti from start to finish.
Precision engineering and ancient tradition combine to deliver the world's favorite pasta.